Thank you guys for coming out. Alright, so I'll give a little intro on myself. So my name is Ryan Green. I'm actually a Newfoundlander, grew up here, went to MUN. So the last couple of years I've been working at AWS. Was at Amazon for about 4.5 years. I was working on primarily API Gateway service, and after that I was working on the Lambda service. Right, anyone familiar with those services? Yeah. Cool. And previous to that, I worked at D2L here in St. John's, and I worked at Verifone for a number of years in the early days. So I've got a fair bit of experience, and I got a lot of cloud experience, obviously working at AWS. So please ask questions during this talk. I can go really deep on AWS specifics, especially API Gateway or Lambda. I can talk about AWS in general. So please ask questions as we go through. I'm not here to sell anything. I'm a recent former employee at Amazon, so I don't have any ulterior motive or anything. But I do. The reason I'm going to be talking about AWS primarily is that because I have a lot of experience with it, and also that I do think it's the best cloud provider. And I wouldn't advocate using multiple clouds. So I'm going to kind of stick to AWS, but a lot of the stuff will apply to other cloud providers. Cool. So I want to start with a little story. This is Essaouira, Morocco. This is a place where I traveled with my family back in the spring. It's a beautiful port city on the Atlantic coast. It actually was also the film set for Game of Thrones, the Slaver's Bay location, so you might recognize it from that. So we were traveling there in Morocco. We got off the bus in Essaouira, and we're at the bus station, and there's a bunch of people hanging around asking if we need a taxi. We're like, yeah, we need a taxi. But, pretty standard. So we negotiate a price with this guy, and he takes our luggage and throws it in this rickety cart. And so we start following him, and we're like, this is weird. Where are we going? And 5 minutes in, we're like, okay, we've been following this guy through these winding streets of the Medina. And we're like, where are we going? Where's this taxi? Where's the park? 10 minutes in, we're like, it occurs to us, this is our taxi. He doesn't have a car. This is our taxi. It's perfectly suited for navigating these winding streets in the ancient Medina. He doesn't need a car. He doesn't need to pay for insurance. He doesn't need to pay for registration and gas and everything. So, he's using the right tool for the job. And even though it was a little uncomfortable for us at first, by the time we got to the hotel, we realized, this is a perfect solution to this problem. So that's kind of a segue into what I want to talk about tonight, which is using serverless, which for a lot of people who haven't used it before, it's really kind of a different way of thinking about it. There's a lot of cognitive friction at first. But my point that I'm trying to get across is that it's pretty awesome for a lot of use cases. Not so awesome for some use cases, and it's pretty easy once you kind of get used to it, but it's definitely a little awkward at first. So before I get into it, just to do a little poll, who here has experience with cloud services like AWS Services? Most people. Who's not using cloud for their job, using an on-premise servers or a data center kind of environment? Okay. So for people using AWS, which ones are using EC2? Pretty much everybody. Is anyone using containers on AWS? Like Docker? Okay. Are you using ECS with containers? Yeah. Okay. Is anyone using Lambda? Okay. A few less hands there. Cool. All right, so I'm going to get into sort of a really high-level, terrible history of the cloud. I'm not an expert on the cloud. I don't claim to be. I've worked there a few years, and I've seen some trends and patterns, and I've been in the industry long enough to sort of see a lot of these things unfold. I started at Verifone in 2007. At that time, we didn't use AWS, I don't think, at all. and they leased super expensive servers and data centers and stuff like that. A lot has changed since then, so I'm going to kind of go through a high-level basic history of AWS compute offerings. So before 2008, this is before EC2. This is kind of like the old school way of deploying software. You'd have, your own hardware. Yeah, I don't want to offend anyone here. Still, a lot of people are doing this today. Yeah, there's a lot of organizations still doing this, especially big enterprises or government customers, banks. But slowly, these people are starting to move over to the cloud. I mean, AWS is working very hard on converting these people, and it'll happen eventually. So yeah, before that, people have their own hardware. They might have data centers. They might lease space in data centers. They might have VMware set up, so they could at least have some virtualization on these servers. 2008, EC2 came out. It was a huge game changer for software development and IT in general. It's allowed people to basically lease virtual machines in the cloud. You can spin up as many virtual machines as you want. Seemed pretty innocuous at first, but it turned out to be a huge game changer based on a bunch of things, which are not quite obvious, but the biggest change, I think, was that the financing model for technology went from capital expenditure to operating expenditure. So instead of putting together hundreds of thousands of dollars to lease data center hardware, you can basically just spin up VMs and pay by the hour. And that allowed companies to be able to innovate really quickly, do lots of experiments. It was hugely beneficial for startups. There's lots written about this whole thing, so I'm not going to go into too much detail on it. But when EC2 came out, that was a pretty big deal. There's been a few things since then, but EC2 is still going really strong, and there's no signs of slowing down. 2011, Elastic Beanstalk came out, which is, I guess you call it platform as a service. Beanstalk basically abstracts away some of the application level stuff, so you don't need to worry about some of the software operating system running on the VMs. So you can think of EC2 as the lowest level, and Beanstalk is on top of that. 2014 is when Lambda came out, so that's the year when I started at AWS. It was kind of an interesting beginning, and it wasn't really set out to compete with EC2 or anything. It was kind of set out to be like an event-driven computing service, that ties in with other AWS services. It evolved a lot since then. For anyone that doesn't know, Lambda is a function as a service. So allows you to write a function, a stateless function, takes input, produces output, described in JSON format, and then you can run it in the cloud and it will auto-scale in the cloud without servers. So you can basically just write your code, deploy it, execute it in the cloud as many times as you want. In 2015, ECS came out, which sort of capitalized on the popularity of Docker, which is it's an orchestration service for Docker. So in AWS right now, there's kind of a couple of parallel streams for compute. You have EC2 and then containers, and then you have functions, which they're all kind of different, and they have sort of different targets, and they all exist in parallel. They don't quite compete with each other. 2017, Fargate came out, so this was a pretty big deal last year. Fargate is a sort of serverless service that allows you to run Docker containers without managing the underlying compute infrastructure. So you can just take a Docker image, throw it at Fargate, and say, run this in the cloud. You don't need to worry about the servers or anything like that behind it. That's still pretty new. That's kind of a big deal. So anyone in the container stream, that's kind of the future of where containers are going. And containers are going to stay around for a while. 2018, there wasn't a lot change in 2018, but reInvent starts tomorrow. So you're going to expect a lot of huge announcements this week coming from AWS. So it'll be interesting to see what new features, what new services they announce. So serverless, I kind of mentioned it a few times already. Does anyone want to take a stab at their definition of serverless? I wouldn't either. So it's basically a buzzword. When I started working on Lambda and API Gateway, serverless term didn't exist. No one talked about serverless. came out a few years after, maybe a year after Lambda was released. So there's a few kind of varying definitions of what it is, but I'll give my interpretation, which I think is the generally accepted one. Serverless services, they use fully managed cloud services. You're not really running your own infrastructure. You're taking advantage of all these cloud services that exist, and they're doing a lot of the heavy lifting for you. You pay per use. So rather than provisioning a resource, you're paying based on how much you use it. So that's a huge one. Don't pay for idle is a kind of a marketing term you hear a lot. So basically what that means is, if your Lambda function, for example, is not receiving any traffic, if it's just sitting there, you're not paying for it. It's free. That differs from a lot of existing services like EC2 or ELB, and you name it, there's a whole bunch, where you provision them. Once it's there, once your VM is there, you're paying per hour. Amazon doesn't care if it's doing anything. It doesn't care if there's any utilization, which is actually a big problem in the industry. Most VMs are just sitting there not doing anything, and a lot of companies will overscale their fleet to account for bursts in traffic, where most of the time their hardware is being underutilized, so they're paying all this extra money for stuff they don't need. So what serverless kind of does is kind of moves that problem to Amazon and away from customers. So Amazon has to solve the utilization problem, how to make all of these Lambda functions run efficiently on servers, but customers don't have to worry about it. You can build an app, and if it's not receiving any traffic, it's free. It's pretty cool. The other property is that it's auto-scaling. So you don't need to worry about scaling up or provisioning it, which is different than sort of traditional cloud services where a lot of them you need to provision or scale. Like DynamoDB, for example, you need to provision a table based on what you expect the traffic to be, and you're paying based on provisioning. Lambda and other serverless services will automatically scale up depending on what the traffic is. And importantly, the server is abstracted away. Obviously, there are servers there, and lots of nerds on Twitter will like to argue about it, but everyone knows there's servers in the background. It's no secret, but it's abstracted away. And the OS and often the runtimes and other things are abstracted away, so you can just focus on writing code and running the code. Any questions?
So what is kind of underpinning Lambda? Is it like EC2-esque things, or is it like something, their own kind of container system?
Yeah. So, yeah, it's when it came out, it actually predated some of the container stuff that was released later. So there is a bunch of internal container-like technology that was developed for Lambda using Linux operating system components, such as C groups and things like that, which allow virtualization on a single VM. And there is a massive fleet of EC2 servers, very, very big fleet of EC2 servers that run Lambda functions, and then custom code to basically figure out how to orchestrate all that. So that's it in a nutshell. I can go into a lot more detail if we have time at the end. It's a very complicated machine. I don't want to rat hole on it too much right now. But, yeah. Any more questions? Cool. Yeah, so the concept serverless predates the term. The term is pretty recent, but there's actually been services around for years that you could say are serverless, like S3, which is actually the first AWS service. Meets all these properties. It auto scales. You don't pay for idle. It's fully managed. You don't care about servers. S3, it just magically works, and that's part of its success, I think. And there's other Amazon services as well that meet that definition, and other services outside of AWS that meet that definition. And you'll see a lot of companies now are kind of piggybacking on the term and using it for marketing and stuff. Whether it's deserved or not, it's pretty common to see. Even old services market themselves as serverless now. So getting into FaaS, which is functions as a service, another industry term. This is really the core of what serverless is. So it's compute basically that's runs serverless. So I added stateless because that's an important property of functions as a service. As far as I know, there's no functions as a service providers right now that provide stateful functions as a service. So what that means is basically a function can take input and produce output, and multiple invocations of that function can't share state with each other. That's what allows these providers to allow it to scale. If there's shared state between, like shared memory, for example, it becomes a very, very difficult distributed systems problem. So as far as I know, they're all stateless, input, output, and mostly speak like JSON in, JSON out kind of thing. So fast is just another sort of industry term. I'm going to talk a lot about AWS Lambda, which is AWS's solution for fast. And it was the first one. It came out in 2014. Other services that you might consider serverless would be like S3, Cognito, which is Amazon's authentication service, API Gateway, which is a team that I worked on, Aurora, which is a hosted MySQL service. This launched with traditional database connections over TCP, but recently just announced a serverless API, which is a API that goes over HTTP that makes it serverless. So like you don't need to worry about managing database connections and stuff like that. That's a pretty big deal, even though it seems subtle. It means that you'll be able to run like relational databases in a serverless way. There's a few caveats here, like DynamoDB, for example. It's kind of serverless, but kind of not. In that a DynamoDB table, you need to provision it. You need to pay for how much you provision it. It's not really truly auto-scaled, but it's pretty close to being a serverless service. So to get in some use cases for like when you would use serverless, seems like not a lot of people here have used it before. So I'm going to talk about like different ways you can use it. And then I'm going to talk about design patterns, and I'm going to go through sort of a demo application. We can look at the code and like see how it all fits together. First use case is the one that basically launched Lambda, was sort of event-driven computing. So the classic example is when Lambda launched was like you have say an image and you drop it in an S3 bucket. You want to automatically generate a thumbnail for that image. So there's nothing triggering that besides dropping the image in S3, and then you have a Lambda function that observes that, generates a thumbnail, and puts it back in S3. That was like the big sort of example used for Lambda when it came out. That expanded into a lot of other stuff later, but that was kind of like what they were targeting. So in terms of event-driven, on AWS there's a bunch of different event sources today. DynamoDB, so you can put an item to a DynamoDB table, it'll invoke your Lambda function. Kinesis streams, you can stream data and invoke Lambda functions. SQS queues, S3 buckets, CloudWatch events. API Gateway, which is kind of a special case, and this is something I worked on a lot when I was on API Gateway, which is API Gateway allows you basically to build a REST API with a Lambda function in the back end. So this allows you to build web services, REST APIs, microservices, all serverlessly. You don't pay for idle. And so that kind of opens up a lot of different use cases for serverless. So when API Gateway came out, that was kind of a game changer for serverless on AWS. So what I've been talking about, web mobile application backend. So API Gateway opens up that use case. You can create a REST API or GraphQL API with API Gateway in the front. And there's a bunch of like open source libraries that exist today that allow you to sort of port existing application code into Lambda. So if you have like an Express application, for example, or Jersey or Spring or Flask Python application, you can basically take that code and import a few open source libraries and then run those in Lambda. And then put API Gateway in front of it. Now you're running an application that used to run on a VM. Now you're running it in Lambda in a serverless fashion. It's probably going to be a lot cheaper. It's probably going to scale a lot better. There's a lot of advantages to doing that. And it's fairly frictionless for a lot of use cases. IoT backends, so this is another thing that you see, which is customers are building like networks of sensors and stuff that speak MQTT and talk to the cloud. and then they might have Lambda functions running in the back end to process the data that comes from the devices and whatnot. Stream processing, so it's actually a pretty popular use case as well, where you might have a stream. You might have a stream of data, and there might be many producers of the data, there might be many consumers of data, and you can have a Lambda function running in the background that processes that data in real time, and no servers involved whatsoever. So on AWS streaming service is Kinesis, and then there's other ones like Kafka and others that are pretty popular. Edge computing. So does anyone know what edge computing means? So edge computing is basically like running the code close to the users. So if you think of like classic cloud example, like the code is running basically in an Amazon data center somewhere. There's a bunch of them around the world, but there's not that many. So if you're in Newfoundland, for example, and you go on Netflix, it's probably going to use a EC2 fleet in Virginia, most likely, which is pretty far away actually. So what Netflix actually does is they have edge locations set up all over the place that they do it themselves. They're not using an AWS equivalent, but it allows them to serve content closer to the users. So if you go on Netflix here, it's probably loading a lot of the content from like a Bell facility or something locally. So that's kind of in a nutshell example of what edge computing is. So there is a service called Lambda Edge, which I worked on, which integrates with CloudFront, which is Amazon's CDN and edge computing solution. So CloudFront, rather than use AWS data centers, they have, I think, 150 points of presence all over the world, which are generally closer to where users are. So you can basically wire up a CDN network that invokes a Lambda function in the back end. So you can do all kinds of fancy things like rewrite HTTP headers and change caching and routing behavior and stuff based on different things. So it allows people to basically build really intelligent CDN networks. There's another service called Greengrass, which is sort of like a hardware device that people can buy and put in their local data centers or their local environments wherever they are. Sometimes they're out in like a farmer's field or whatever. And then that can run basically this sort of subset of AWS services right on the hardware. So you can basically build a Lambda function and deploy it to a Greengrass device like in a farmer's field and have the tractors call Lambda like locally in the same field rather than having to go out to the internet. So some interesting stuff going on there in IoT and edge computing and stuff. I'm not going to go too much into those examples. Workflows, so complex workflows, which, if you had to do this traditional way, you'd have to you'd have to write a lot of code, you'd have to use a lot of infrastructure. It'd be fairly complex to run long-running, complicated workflows. There is another service called Step Functions, which allows you to build a workflow using Lambda serverlessly. And you can build a workflow that can run for up to a year. It can require human intervention. There's like logic and retries and everything built into it. It's super cool, and it just uses Lambda as a compute engine in the background. So it's like a really compelling solution for doing workflows in the cloud. Yeah.
But so Lambda times out at 5 minutes. So there's a separate thing that is on top of Lambda. That's
right.
Okay.
Yeah, and actually Lambda times out at 15 minutes now. They just increased it recently, and they're going to keep increasing it. But that's a good point. So if you're building a complex workflow that, like, say, it took several hours, you wouldn't be able to do it all in Lambda. You would have to use step functions, and that would orchestrate different functions that would run for shorter amounts of time. So if you can break down your workflow so that it runs in like 15-minute blocks, or the steps run in 15-minute blocks, then step functions will do the orchestration. That can take a year before it times out. So it won't work for all use cases, but it works for a lot of use cases.
Cool. Thanks.
Schedule processing. So if you need to like run some code periodically, like a cron job, you can do that using CloudWatch and Lambda. So that's another awesome use case, and it's super easy to do. Alexa apps. So Alexa integrates natively with Lambda. I don't know what the numbers are, but like a very high percentage of Alexa apps are using Lambda because it's so much easier than doing it the traditional And Alexa is a perfect use case because it's not really steady traffic for most people. It's just going to like run the code every now and then when you interact with this skill. So it works really well. All right. Any questions so far? Okay. Have a sip of beer. So I kind of touched on it already, but there's tons of advantages for using serverless. Again, I'm not selling anything. I really believe I've used serverless. I've used traditional, and there's a lot of really compelling advantages if you're a developer or an organization who's paying the bill for building things in this way. One is that you don't need to worry about scaling as much. Like Lambda, for example, automatically scales based on the workload. So if you're a startup and you have no customers, you're not paying for anything. All of a sudden, if you have thousands of customers, the same solution will work in general, and you just pay for what you're using. So it scales up really well. It's good for bursty workloads where you might not have any traffic for a while, and then all of a sudden it's like Cyber Monday, and like your website is not going to blow up because it can handle a scale. So yeah, I mentioned this earlier, but like VMs and containers traditionally have very low utilization because they're so slow to scale up. Most people would just, you might have seen this in your own job, but you would provision your number of servers to be higher than what you need. Because in case you do get a flood of traffic, you'll be able to handle that traffic. Which means the rest of the time you have just a bunch of VMs sitting around doing nothing. It's a huge problem in the industry. It's a huge problem even at Amazon internally, and it's a big reason there's such a big push to go serverless because it forces the fast providers to solve this problem. And not every company in the world should solve this problem. It should be like one of the cloud providers should figure out how to solve the utilization problem. You get automatic redundancy, so you might be familiar with availability zones in EC2. So you can have EC2 instances in multiple availability zones and fail over. The AZs are actually like different data centers, so you can imagine in the same regions. You can imagine if there was like a fire in one of the data centers. As long as you had your code running in one of the other data centers, you could fail over, and you'd never have any downtime. So that's if you're using EC2, that's kind of a recommended way to use it. You'd have AZ redundancy. With Lambda, you get that for free. You don't have to do anything. Lambda just automatically runs all your code in multiple AZs. Security, which is sort of a controversial topic, but I would argue that using something like Lambda is more secure than using lower level cloud resources like EC2. EC2, you got to configure your security groups and your VPCs and ACLs, and there's like a lot of places you can screw things up. With Lambda, you basically have to configure a role. So that's the role that your function uses that gives a function permission to do different things in your AWS account. As long as you are careful about how you define that role, it's a lot easier to make your software secure. And then API Gateway, there's some security best practices with that as well, and other serverless services. But in general, there's a lower surface area of things that can go wrong. Yeah, so you can get a lot faster time to market with something like Lambda. You can build and deploy stuff really quickly. You can do experiments really cheaply, like if you're a startup or you're a company that wants to just try another side project, you can build it really quickly using serverless. You don't have to worry about like all the infrastructure and everything. So more advantages. Cost. Oops. It's generally pretty cheap, depending on what the workload is. I would say for most people, running serverless would end up being cheaper. It's only the people that have like really high scale. There's at some point where it crosses over, where if your traffic is super high, it's going to be cheaper to run it on EC2 or on containers or something. But for most people, which most services have generally pretty low traffic, Lambda will be cheaper. And there's a free tier, so if you have less than, I think, 1 million requests a month or something, you don't pay anything at all. And you'd be surprised how many applications qualify as a free tier. You don't pay for idle, so if nothing's running your code, then you're not paying for anything. And it's simple, so there's a lot of stuff you don't have to think about as a developer, which I love. You don't have to think about hardware, you don't have to think about operating system, you don't have to apply security patches and updates. You don't really need to think too much about infrastructure. There's no load balancers, no VPCs, no security groups. Like the list goes on and on. Interesting thing I've seen since I've been here and just chatting with companies around town is a lot of people that focus on application development, they don't really want to focus on infrastructure, and vice versa. And like you see teams with like infrastructure developers and application developers, which like coming from Amazon, I find it really interesting because we never did that. Like you kind of do everything at Amazon. You do the infra, you write the code, you deploy it, you operate it, like you own it end to end. So be that as it may, with serverless you don't even need to have that problem. With serverless, there's way less focus on infrastructure. It's way easier to deploy your code. So you don't really need to have a split and have like a DevOps team or infrastructure team. Any questions about that? So there are some disadvantages, which it's important to talk about. Does anyone know what cold starts are? Yeah, all right. So it's probably the biggest thorn in the side of fast providers, which it's pretty hard to build an auto-scaling, don't pay for idle, fast service without having cold starts, which means if your code's not getting invoked for some time, the cloud provider is going to basically put it to sleep. And when it gets invoked again, it'll wake it back up. So most times, like usually only affects like the 99th percentile or the 100th percentile. You'll see much higher latency for your function. So it might be like a second. Like you might have a function that runs in 100 milliseconds, but every now and then you'll see a second because it has to, spin up a new container, has to download the code, has to start like a JVM or some kind of class loader or something, and all that time contributes to a cold start. So for customers that really need highly latency sensitive performance, fast probably wouldn't be a good fit. It depends on what you're trying to do. So lots of people build web applications, mobile applications using Lambda and other fast solutions, and the latency trade-off is okay for them, but it depends on the use case. And cold starts are getting better all the time, so it's one thing that the teams are working very hard to optimize is getting the cold starts down. They'll get better over time. Eventually they'll become negligible. I don't know how long it will take, but it'll get there eventually. And the other thing I should mention is that some runtimes perform worse than others. So for different reasons, depending on which runtime you use, like Lambda supports Node, Python, Java, C#, a bunch of others. And some perform a lot worse, like Java is one of the worst because the class loader has a big penalty and stuff like that. So something to keep in mind if you're using Lambda.
What would you say is the best? Best?
Python is good, and Golang is, I think they're the two top performers. They're pretty close. Node is pretty good. They're all pretty close to each other. But I think it's like Python, Golang, Node, and then Java, and the other like static languages, which are the worst.
Could you write a Lambda that triggers on a CloudWatch cron that's just before like the eviction time to keep your app hot?
Yeah, and actually, it's kind of a hack, but a lot of people do that.
Okay.
Like, it's crazy how many people do that,
Yeah.
and it's a workaround that kind of works. It doesn't work perfectly because it assumes sort of a certain level of traffic.
Yeah.
If all of a sudden you get more traffic than you expect, then your warmer function is not going to work anymore. But that's actually a recommended workaround right now,
Okay.
believe it or not. But you're paying for that too.
Yeah.
So,
But you're keeping one node up, hopefully. And,
yeah, exactly.
Yeah.
I think there's even like external services that
Okay.
just solve it. It's crazy. So as I mentioned already, it can be more expensive at scale. If you're building like a huge high traffic service, it's going to get pricey. And so I mentioned like kind of like the discomfort of trying things in a new paradigm, which serverless and Lambda is a new paradigm. The development and test and debug sort of life cycle hasn't really caught up yet. It's not quite where it is for traditional applications. The tooling for like integration testing and deploying and testing locally and stuff is not quite there yet. So it can be that can be a little bit painful at first until you figure out the right workflow that works for you. But it's improving. It's getting there. There's no real debugger that you can run in the cloud right now. So like if you're running a Lambda function in the cloud, you can't put a breakpoint on it and like inspect it. There's a lot of like logging and stuff that gets done, and there's an AWS service called X-Ray, which allows you to trace a request through different AWS services, which is pretty helpful, especially for performance issues. But it's not like debugging a traditional application where you can just like run it locally and put breakpoints in and test it out. So it's a bit different, and it's a bit of a pain point right now. Not all web server frameworks work in Lambda either. So if you're building like a backend, you can't just drop any application in Lambda and expect it to run, especially stateful frameworks, which don't really scale anyway. They're not a great idea in the first place, but there are a bunch of open source tools that help with dropping like an Express application into Lambda. And most of the libraries are covered, but there's still a bit of a mismatch with getting things to run in Lambda. Like you have a 15-minute timeout, and you don't want the latency of like starting up a web server in your Lambda function. Different ways of building a solution using Lambda and S3, but you wouldn't be able to reuse the same code. So I mentioned cold starts already. This is a graph that I stole, which shows someone did like a performance test of cold start times. So these are the, as I mentioned earlier, Python, Golang, and Java. Okay, that's surprising. This has got one guy that did a test. I don't know if this is super accurate, but it just gives you like a basic idea. So some cloud providers are slower than others. Some platforms, some runtimes are worse than others. All right, keep going. Any questions about that? Cool. So I'm just going to talk about some patterns, different ways people use these services, different ways you can build things using these services. And once you get these patterns, like it becomes super powerful. I'm going to give a demo after, and we can look at some code. But it's super easy to build like a web application or different kinds of applications using Lambda, using S3, API Gateway. And it's super powerful, it's cheap, performs well, scales well. It's pretty nice. So I'm going to just talk about different patterns and ways you can use the services. So a common one you'll see is serverless websites, like static websites or JavaScript sites. Has anyone seen this pattern before or used it? Yeah, it's a really nice pattern. So you basically store all your code in S3, your images, your JavaScript, your HTML, whatever. And then you can optionally use CloudFront, which is a CDN network, which will provide an edge cache. So people visiting your site, they'll get a cached version. It loads super fast. You can assign a custom domain name to the CloudFront distribution, and you can assign a SSL certificate to that CloudFront distribution. So you basically have a SSL-powered website with an edge cache and CDN, like for super cheap, and it's really easy to deploy code, and it just works really well. So it's kind of a sweet spot for S3 and CloudFront. And I'm going to talk about how to extend that pattern a little bit more to have like a web server with backend code that you can run and have databases and stuff too. So yeah, this is it here. So you can build a backend. So the pattern is I want to build a backend for a web or mobile application. It's pretty common. So basically you'd use API Gateway, create a REST API, which uses HTTPS, and you have a Lambda function or multiple Lambda functions in the backend that do all the business logic. And as I mentioned, you can port over existing web server frameworks and run them in Lambda. So this gives you a serverless mobile or web application backend that scales automatically and is pretty cheap to run. You can also use other services like Cognito, which provide authentication and authorization. That's another serverless service, so there's no servers to worry about. And then you can wire up whatever backend data store you want, and then you have your full web application stack. There's also another service called AppSync, which is pretty new, which is kind of targeted toward mobile app developers. That one will allow you to create a GraphQL endpoint for your mobile application. It has like offline data syncing capabilities and integrates with Dynamo and a bunch of other stuff.
Just a question, and we might talk about this later in the presentation, but in the previous pattern, how do you recommend people do deployment of all the Lambda functions? Like, assume they're probably storing all these in their own Git repository. What does the pipeline look like between the Git repository and the live Lambda functions? And
Sure.
does AWS have a service that you recommend using between there, or is it
yeah.
writing custom kind of continuous deployment code to handle it?
Yeah, so the answer is basically whatever you want. AWS is pretty unopinionated about that, and it's actually amazingly easy to build a continuous deployment pipeline because the primitives that you get for deploying are basically the AWS SDK and the AWS CLI. So if you want to deploy a Lambda function, it's like a single command you can run with the CLI, or you can do it with SDK in any language you want. And there's some other alternatives, like frameworks like the Serverless framework, and there's another one called Serverless Application Model, which is AWS's official supported one. And then that allows you basically, it basically makes it easier to package up the entire application and deploy it all as one. It actually uses CloudFormation behind the scenes. So the answer is, the best deployment mechanism that AWS provides is CloudFormation. That's the one that's going to be the safest, and the one that's going to be have all the new services and features added to it as time goes on. There's a lot of things that kind of compile different things to CloudFormation. Like SAM, for example, basically converts a SAM template to a CloudFormation template using CloudFormation template. There is, in terms of pipelines and stuff, there is Code Deploy, which is AWS's solution for deployment pipeline, and that integrates well with all these things. But you could also do it on Jenkins. You could do it on your laptop. You can do it anywhere. It's pretty unopinionated and pretty easy to set it up.
Cool. Do you recommend something like serverless framework? Are people still using that?
Yeah, it's still popular. It has all kinds of cool plugins, which is what I like about it. There's a lot of community support. But as I said, like CloudFormation is sort of the official gold standard, and SAM is this sort of easy layer on top of it. That's the official AWS supported standard. So I would recommend SAM. Okay. Not SAM, not this SAM. Oh, I would recommend this SAM, but that's not yeah, so serverless application model, which I will get into. We'll look at some code after. Streaming. So has anyone used like streaming pattern like at work? Yeah. What are you using it for?
Yeah. Essentially, there's like an easy answer. For pulling in features from machine learning stuff, so streaming data from whatever into some sort of warehouse for later analysis.
Okay. Yeah, so there's a lot of different ways you can use streaming. It's kind of in vogue right now, event sourcing and stuff. Yeah, there's a lot of applications that work really well with streaming, like click streams and like advertising data and like analytics and stuff like that. So basically, you have a stream of data, and then you have something on the downstream of that will process the data as it comes in. So for AWS, Kinesis is a streaming solution. It's probably not my favorite service. It's kind of an older one. It's got a few sharp edges. I suspect in reInvent this week there's going to be some new announcements around that. We'll see. But Kinesis integrates well with Lambda, so basically you can, and I'm going to show this in the demo. You can stream data from multiple, even millions of devices to a single stream, and then have like a single Lambda function that just processes data on the downstream. Yeah, so the way Kinesis works is it sends a batch of events to Lambda, so you can configure that. So you have a stream of data, and then your Lambda function will get invoked with like 50 different events, and you can do stuff with it. It's kind of abstract to talk about, but it's a pretty common pattern, and it's trendy right now in that a lot of people are talking about not using databases in a traditional way anymore. They're talking about having an event log of every event that ever happened since the beginning of time in your application, and then building materialized views out of that, which you could easily do using Lambda and Kinesis. So there's some interesting possibilities there. I think there's going to be some trend in the future. Lambda also integrates with SQS, which is a super scalable queue service, like a message queue. So you can use that for streaming as well. Schedule jobs, which I already mentioned. You can build a cron job in like 10 lines of code with Lambda and CloudWatch. You can just have your function execute every however many minutes. It's good for background processing. So the workflow, which we already talked about a little bit, this is an example of a step function state machine. This is one that I built for a blog post, an AWS blog post that came out last year. So this is kind of like a visual representation of the workflow. Each node is a Lambda function that runs. And then you can have step functions deal with all the loops and conditions and error handling, retries. And you can build in human steps in there, like if a human needs to approve something, they can go and approve it and continue the workflow and so on. Allows you to build like super robust workflows using step functions in Lambda. Yeah, there's a link to a blog post in the slides of a step functions example. I'll post the slides later if anyone wants to look at it. So in terms of adoption, while I was on Lambda and API Gateway, I saw a few different patterns, especially for companies that already have solutions in play. They kind of want to like get their feet wet a little bit with serverless before they like dive in. So they'll build like side services or like experiments or little kind of scheduled services or kind of like not their critical path services. They'll use Lambda for it. But you'll see a lot of startups and new companies. If you're starting from scratch today, Lambda would be, or any serverless provider would be a compelling solution to start with. It would save you a lot of time getting to market. So you'll see that as a pattern for startups. And sometimes you'll see companies just take an entire web application that already exists and like, drop it into Lambda with minimal changes. So we talked about tools a little bit. There's a lot of tools out there. It changes like every week. The gaps that AWS has are kind of on the client side, kind of on the tooling side. They don't really focus so much on tools as much as services. So you'll see the open source community kind of step in and build things like Serverless Framework, which used to be called JAWS, which I worked closely with when I was on API Gateway before they launched. Is a solution to sort of help make serverless development easier. Allows you to package your application up and describe it and configure it and deploy it all as one unit. So that sort of like grease the wheels a little bit for adoption. AWS released their own version called SAM, which I already mentioned. There's another tool called SAM Local, which basically lets you run your functions locally, so you can debug and test locally, which is super nice. You can actually run debuggers and run unit tests and stuff like that. The AWS CLI and SDK are super powerful. For anyone that's used them, probably wouldn't know. You can deploy Lambda functions, API Gateway, whatever AWS services using the SDK and CLI, and related CloudFormation, which CloudFormation is the descriptive format for how you describe all your resources. So you could have a configuration file with everything defined and deploy it with a single command. There's a bunch of deployment tools that are in those same vein. In terms of testing, a lot of people struggle with like how to test their Lambda functions because it's kind of weird how you have a function that's running the clouds using other cloud services. There's no like local development per se, like it's different kind of way of thinking. You can mock out all the other services you're using, but then it kind of defeats the point. You're not really testing your code anymore. So unit testing is valuable to a point, but integration testing using real AWS AWS Services live is much more valuable. There's a distributed tracing service from AWS called X-Ray. It's pretty cool. So it allows you to basically trace a request. Say you have a request that goes through API Gateway, and then it goes to Lambda, and then it goes to DynamoDB or something like that. You can trace a customer request the whole way through the system, kind of like the Chrome developer tools thing. You'll be able to see the timings and debug information, contextual information as it goes through the system. So it's really good for distributed debugging. Still pretty new. People are still trying to figure out kind of the best way to use it. There's a lot of web server platforms that I've already talked about, like Express, Spring, so on, that exists. And there's open source tools that allow you to port existing applications and run them in Lambda using these frameworks. Any questions? All right. So I'm going to give like a super silly demo. It's just a little application that kind of demonstrates some of these patterns. The idea was like sort of have a Facebook Live. Facebook Live, you can like something, and there's like a stream of likes that kind of float by. So that was the idea. So the patterns that I'm using in this demo, we have a web application that's hosted in S3. There's a web application backend that's hosted in API Gateway. There's a stream of data, which is the likes that are coming through. And then there's a background process that runs periodically. So there's a few moving parts here in this application. And I'll give a quick demo, and then we can go look at how it's all wired up in the code and how it's deployed and stuff like that. So it's pretty cool because all the code is in one Git repository. There's a single file that defines all the resources. There's a few code files. There's a fully built React app with a Go pipeline. It's all just in one project. You can deploy it with one command, so it's pretty nice. And it's pretty much free. So, if anyone has computers, feel free to hit this URL. Can you see it? Sorry. All right. So someone's already clicking like. This might break at some point. I haven't really tested it yet. So yeah, you can see what's going on. There's a like button here, and when you click it, it basically sends an event to a stream in Kinesis. And there's a web application built in React that's polling the stream and just like showing the likes as they flow through. And then what's happening is there is a Lambda function that's wired up to that Kinesis stream that takes the like and stores it in Dynamo. So we have like a permanent record of all the likes. And I'm not doing anything fancy with the data. I'm just like sticking it in Dynamo. But that shows up in this table here. So this is basically like an audit log of every click that happens. So that's the stream processing side. And then down here, I have a graph. So there's a function that runs every 5 minutes, so it hasn't updated yet. The function will take all the data that's stored in Dynamo and generate a report that shows which users click like the most. So the function basically takes the data, crunches the numbers, and counts based on the user. So the user is based on a Cognito identity. So this app actually has auth basically built in. There's no login. It's all unauthenticated, but every user that goes to it is identified by a cookie, and we can like distinguish between all different users using Cognito, which is pretty nice. So I'll check back on that in a few minutes and see if it's updated. So here's the architecture diagram. So you can see there's a CloudFront distribution in front of the user, which I'm not actually using in this demo, but it's an optional thing to add CDN and edge cache. The website is hosted in S3 bucket. It's a React application, JavaScript, and HTML that's sitting in the S3 bucket. It calls an API gateway API that then calls a Lambda function that provides the backend. The Lambda function loads data from DynamoDB. The application in S3 also, when you click the like button, it sends the data to a Kinesis stream. So all the events go on that stream. And then there's a Lambda function that processes the events from that stream. And then stores those events in the Dynamo table. Does that make sense? Seems confusing, but and there's a schedule function that runs every 5 minutes, takes all the data from the Dynamo table, generates a report of the counts of all the users that clicked like in the last 5 minutes, and stores that in another Dynamo table. So that's what gets loaded in this graph. And we have a graph, so it's like we have a bunch of unique users, which is cool. So whoever this GUID is winning. Good job. Might be me. Click 70 times. Any questions about that architecture so far?
Why did that graph keep being regenerated if it's the state there is staying the same? It doesn't change.
Yeah, so this is generated by the backend. So yeah, that's a good question. It's just a stupid way that I built this, but this polls I think every 5 seconds or something. But the backend doesn't update the graph until every 5 minutes. So this timestamp is based on when the graph is actually generated, which is every 5 minutes. I should change this to reflect more like realistically what the 5-minute poll rate. So I'm going to go through the code. It's all on GitHub. I'll share that later. It's kind of just an example of design patterns, so don't use the, especially the React code, don't use that as like a best practice example or anything. I use some anti-patterns the way I was using DynamoDB too, but it's, it gets the point across. So this is basically a full web application stack in not that much code, which we're going to go into now. All right. If anyone wants to look at the code, rpgreen/NDev demo on GitHub. Any questions about that? Straightforward? Cool. So this is a project. Go through it on a high level first. There's a few major components in the code. There's a template.yaml file. This is a SAM template. So when you work with AWS, especially as services get more mature and more abstract, your life becomes editing YAML. And that's like a normal thing. So take it for what it is. It's kind of nice because a lot of things are abstracted away. So basically my entire project is described in this YAML file. All the resources, all the permissions, everything is defined here. Everything except the function code. So the function code is stored separately. And all these functions are written in Golang, and they're super simple. They're just like a few lines of code. And most of the complexity in this architecture is in the infrastructure template, which is actually pretty straightforward too. It's just a bunch of resources. So if you go in, you can see there's an S3 bucket, which is the website S3 bucket. There's a policy for that bucket, which says that it's public bucket. You can use it as a website. There's a Kinesis stream that is the stream of all the likes that come through. There's a Dynamo table with a key that stores all the events, all the like events in a Dynamo table. There's another table called top likers, which is the one that generates this report. So that's stored in a separate table. And then there's a bunch of Lambda functions. So the Lambda function, this is all you need to describe a Lambda function. And it points at the code which gets built as part of this deployment script. I have a 20-line deployment script, which is just super dumb. It doesn't really do very much, but just this amount of code is all you need to deploy everything into whatever environment you want to deploy it into. So yeah, the Lambda description just points at a zip file with the compiled and zipped Go code. And you can see here there's a proxy API attached to it. So that actually is a nicety of SAM that basically builds a API gateway REST API for you, and then provides it on /likes resource and HTTP method get. So just by adding those few lines of code, I have a free REST API. It's a really nice thing about SAM. If you had to build this in API gateway separately, it can be really confusing because we made API gateway really confusing when we built it.
Really powerful.
It's it is.
That's what
It's
you
a
say.
Swiss Army.
There you go.
So I have 4 Lambda functions here, they're all defined here. Pretty much copied and pasted this block of code to create all 4, and you just change a few things. This one you can see is attached to Kinesis event source. So when there's new events on the stream of likes, it invokes this consumer function. This consumer function basically just takes the Kinesis records that come in the stream and basically just save them to a Dynamo table. That's all it does. You can imagine that you could do a lot more fancy stuff here if you wanted to. But this is just like a really straightforward example. What else? Yep. So there's just a bunch of functions here. One that builds a report. This one's tied to a CloudWatch schedule that runs every 5 minutes. There's a cron-like expression here. So this function runs every 5 minutes. It scans the table of all the likes, gets all the likes from the beginning of time. In the last 5 minutes, and then builds a report of the counts of the users and the number of times they hit like within that 5 minutes, and returns that as a big JSON log. So I can actually show you that running in real time. So these are the logs that are coming in from the consumer function. Oh, there's a lot more people now. Sweet. So you can see the CloudWatch logs that are streaming in, and they're basically printing out the Kinesis records and showing what gets stored in Dynamo. So CloudWatch logs and CloudWatch metrics are one of the main tools you'd use for debugging and monitoring your service, especially in production. They're pretty nice tools. So
what's going on there? You're not running anything locally there. You're just
No.
hooked up to CloudWatch.
yeah.
Okay.
So I'm actually using this open source tool called Saw, which is just like a little layer on top of the AWS CLI, and it streams logs from CloudWatch. So it's nothing locally. I tend not to run much locally. I might have unit tests that like test like the business logic of a function, but really if you want to like test everything end to end, which this one you're testing the connection with Kinesis, you're testing the connection with Dynamo. There's a lot of moving parts. It's hard to unit test all that stuff. So you would use CloudWatch logs in production or in AWS to monitor and troubleshoot. Yeah, so that's the one that takes the report of the top likers and stores it in Dynamo. Yeah.
Is that template YAML all generated by hand, or is there anything that gives you kind of like a template that you fill in, or is it just
Yeah.
over experience?
So this one was generated by hand. There are different like tools to make this easier. Things exist like Terraform, and I think there's some new tools coming out soon that are going to help with this. But basically, it's a lot of copy and paste and trial by error kind of thing. It's the state of things right now, unfortunately. This will become higher level later at some point, but it's not there yet. And this is essentially CloudFormation. This syntax is CloudFormation syntax, but because it's serverless application model, there's a few bits of sugar that make it a little bit easier to deploy Lambda functions and things like that. This basically, when you deploy it, it generates a CloudFormation template. This is the actual build time artifact which is a huge CloudFormation template for the whole project. What else is here? So there's also some Cognito stuff. So Cognito provides authentication, authorization. So you can actually have a full auth system built with Cognito. And right now this application doesn't have authentication. It's just unauthenticated users, but it's enough to be able to identify like everyone here that's using it. You can add a lot more features onto that. So there's a Cognito user pool, which is like what they call like, all the users of the system, and an identity pool. You can also wire this up with like social identity providers like Facebook and Google and stuff, and make it really easy to build auth in your application. And then there's a bunch of permission stuff. So every Lambda function needs a role, an IAM role, which specifies what the function can do, is allowed to do, and they're all defined down here. There's a lot of boilerplate code, but it's super important to give least privileges to your functions. So I could have used the same role for every function, but I didn't want to set a really bad example and have people copy it. So each role here basically specifies only what that function is allowed to do. This one is allowed to call Dynamo get item, Dynamo query, and Dynamo scan only on the likes table. You can't do anything else. So it's a super important thing to do for security. So there's a lot of boilerplate for all those roles. So you can see there's like 500 lines of code here, but it's mostly just like copy and paste in YAML. But it's actually pretty easy to work with once you get used to it. It's just a little awkward at first. Yeah.
So could you set up like a dev or like a staging environment outside of production just by using like different roles and permissions from them?
A dev or staging environment, you wouldn't do it like that typically. You could definitely partition it based on the roles. So like the dev function is only allowed to talk to the dev table. The recommended way is to have different AWS accounts completely. So the courses unit in AWS is an account. It's really hard to have one account access resources of another account. You can do it, but it's a really roundabout way. So the recommended way is to like have a dev account, have a beta account, a production account, or a test account. Keep it all separate. You deploy the exact same template to each account, and there would be different stacks. And you can parameterize templates too. So if you're not familiar with CloudFormation and use AWS, or you're not using any infrastructure as code, I highly recommend using one of them, like Terraform or CloudFormation or SAN, because it's so much better than having to manually manage all the infrastructure. And it's safer, and it's just better in every way. So everyone should be using infrastructure as code if they're not already. In a template, you can have parameters, so you can specify. You can like pass in different things. So you can like, if you wanted to, you could use the same template and set a few parameters for dev and then different parameters for production. So it's pretty flexible. And then I think I showed the deploy script, but it basically it's not very smart. It builds the Go code, it zips it all up in the zip files. It builds a React site. It deploys the SAM template, which actually uses CloudFormation to deploy it. I'll run it, so you see. And then it deploys the site to S3, which just uses AWS S3C. And that's your website deployment command right there. So this is building the React site now. It's probably really slow. So this is a tool that I wrote that basically streams CloudFormation logs for your stack, so you can see what's happening with it. So when I deploy this with CloudFormation, the SAM template will get compiled to CloudFormation and get deployed. All the resources via CloudFormation. We can see the progress of it here. And so like you can see it's pretty easy to deploy stuff. If you had a CI/CD pipeline, basically your CI/CD pipeline could run this script, and you're pretty much done. So you can see like the functions are getting updated. Update complete. So pretty straightforward. Any questions? All right, I'm talking your ears off, so let's go wrap it up. Cool. I'll send out the slides after and the Git repository and stuff if anyone wants to take a look later.
I have one question.
Yeah.
Dynamo seems to fit really well obviously into an AWS Lambda serverless type architecture. How much do you like Dynamo? I mean, we're using Mongo, and a lot of people are using Mongo. I've played with Dynamo. I've been cautious about using it for like a full-blown application.
Yeah. So, as I mentioned earlier, like some things are a little like awkward at first, and then once you really get used to it, it becomes awesome. So Dynamo is one of those things. Its API is really weird, and there's a lot of quirks with the service. It's been around a while. But once you start using it and get used to it, and you're using it in production, it's awesome. It's like amazing service. I've used it. We used it as a backend data store for API gateway, and it's used by Lambda. It's used by almost every AWS service. Super powerful. It's super reliable. It performs really well. It's just that, like the API for programming with it is a little weird, but once you get used to it, and once you kind of move from a relational database background, it's a lot different. But it's not so different from Mongo, which is sort of a document store. But you don't have transactions and stuff like that. You don't have joins and relations and things like that. So you kind of have to like architect your data store a little bit differently with Dynamo. I think that's probably true with Mongo as well.
Yeah.
And they're adding auto scaling and stuff like that. So you don't have to provision as much. You can have it auto scale your tables along with your traffic flow and stuff like that. So I'm a huge fan of Dynamo. I would use it in a heartbeat for new projects.
Yeah.
The scale, mainly because it scales really well and it's cheap. You like once you build it, you don't have to worry about it. And, you don't need to worry about scaling horizontally or anything like that, or managing servers, whatever. So,
Would you use an architecture like you just showed? I mean, I guess if you were building a new app, say it's like a standard CRUD web application, startup, something like that, would you very seriously consider using a serverless architecture?
Yeah.
That's what
This is basically the architecture that for most applications that I would propose.
Yeah.
There's some cases where I would change some things, like
you wouldn't go back to like Elastic Beanstalk or two instances.
no, or even containers.
Yeah.
I'm not even a big fan of
Yeah.
containers. I think that there's a couple streams right now, and I think that containers are going to eventually become a thing of the past. And for like people that are building cloud services, they're going to use containers. Most developers aren't going to care about containers. They're going to just want to write the code and like run it. So I don't even invest any effort into learning containers anymore, like Kubernetes and stuff. Like I gotta waste my time on it. It's like the ship has sailed, I think, in my opinion.
Okay.
So I would recommend this architecture. The only time where it wouldn't is if you have like data which is highly relational, or if you have data where you like really need strong transactions. Dynamo wouldn't work very well in that case.
Right.
So if you're building like a banking system or something, probably wouldn't use Dynamo.
Right.
But for most CRUD web applications, most stuff you see, I think it's a good fit. And I think Dynamo's working on these problems too. Like they're going to eventually solve transactions and other things. So it's getting better all the time. And there's also Serverless Aurora, which is like the Serverless RDS equivalent. So you can still basically swap out the Dynamo in this example with like Aurora and use MySQL transactions or Postgres or whatever. So yeah, this is the architecture that I would push if we're starting new projects. Definitely. So yeah, we kind of started talking about the future a little bit. I'm just gonna like wax on some opinions here, yeah. So there's another AWS service called Serverless Application Repository. It's pretty new. It's not super useful yet, but the intention is that's going to be like a big repository of serverless applications. So basically that template that I just showed you, the idea is that I can publish that in the repository and other people can deploy it to their AWS accounts. The ultimate vision, I think, is that we'll be able to have composable apps. So like I'll be able to build certain parts of the architecture, and you can build an application and take components from here and components from here and put them together and build the full application. So I think as that evolves, that's going to be pretty powerful. And eventually you'll be able to, invoke other people's functions and maybe pay for them. Like if I write a function, you can invoke my function and you have to pay for it. That'll be a thing that will eventually happen. And so for Lambda right now, there's like a handful of runtimes, and there's no way to run like agents in the background to collect logs or anything like that. It's all just done by the Lambda team. Eventually, there'll be custom runtimes where you can specify whatever runtime you want. If you want like PHP 1.0 or something, like you just like bundle it up yourself and like do it yourself. Lambda's not going to keep supporting these runtimes forever, and you'll be able to have agents that run in the background and do various things in the background. As far as containers go, containers aren't going anywhere for a while, I don't think, but the way you use them is going to evolve. I think Fargate is going to be pretty big, where instead of having EC2 fleet and deploying containers to it and managing all the orchestration and stuff, you basically just have a Docker image and say, run this Docker image, or scale up a fleet with this many Docker images, and have AWS worry about all that. So Fargate, I think, is going to keep growing, and it's going to be a pretty useful one. Yeah, we already touched on it, but I think containers are going to be more niche and more geared towards like people that are building like cloud systems and people that are building applications and general purpose services are going to be using containers less and less, and they'll probably be using serverless more.
Do you see like the managed container services, sort of managed Kubernetes services, picking up some uptake in that area as well then?
So
same as serverless? Just deploy an image and let the service provider orchestrate it.
Yeah, similar to Fargate. I think
Yeah,
I'm not an expert on Kubernetes.
GKE, all that.
Yeah, I'm not an expert on Kubernetes, but I think in general what you'll see is like Kubernetes is very complex to operate, and you'll see those things being used by people that are running certain types of services, and the broader development community will be using less of those. Yeah, like you shouldn't have to like jump through hoops to deploy a CRUD application. You shouldn't have to learn Kubernetes to deploy a web application. So I think that like if you're building Lambda today, you might use Kubernetes or ECS or something like that. Yeah, and these cloud providers are moving up the stack all the time. It's constantly evolving and getting higher level all the time. So it makes it easier for regular developers of just building applications to not have to worry about the infrastructure and all the moving parts behind it. Yeah, there's going to be better tooling. So I already mentioned some of the gaps in tooling. It's like hard to test, hard to debug. It's a little awkward right now. Logging is a bit weird. Unit testing is a bit weird. So there'll be more client-side tooling, better frameworks and stuff like that, evolving as time goes on. And I mentioned the cold start problem will keep getting better. And you're starting to see some services now that there's just not even any code at all, which is kind of interesting. The example I show, you execute code in Lambda. The code is not doing that much. It's taking like data from Kinesis and putting it in Dynamo. You almost don't need to write code to do that. Like you can imagine if that was just in the YAML as a description of transformation or something. So you're starting to see some services do stuff like AppSync. Basically allows you to wire up a GraphQL endpoint with data sources, like including Dynamo and other ones. And as far as I know, you don't really write any code to glue those together. You can just like define the data transformations and the service does it. So you're going to see more like high-level services like that, where people can build applications without actually writing really any like imperative programming code to do it. Any questions? All right. Thank you, guys. There's my Twitter. There's my email. Feel free to reach out. I am available for hire if anyone needs help with AWS or Serverless. I'm consulting in town right now, so reach out. This is a picture of the taxi cabs in Morocco that we didn't take. Any more questions?
Just because I don't think many people have worked at like one of the bigger Facebook, Amazons of the world, can you talk about just like the development process at AWS with Lambda, like working on a feature, like what's the process for actually getting that in the world? Like, is there like just normal like Git pull requests, or is there like just so much specialized stuff because of the size?
So the process is not so different, but I would say that it's a very mature process, and the tooling is the main differentiator. So I've worked on various different teams, different sizes, different levels of maturity. At AWS, you're an AWS service, like there's a gold standard that you follow that gets applied across all teams, and it's very rigorous. So basically, you would have a CD pipeline. So the development process is pretty much the same. You develop a feature, you test it locally, different ways, integration tests, unit tests. You test it maybe in a test environment. That's like production, and then there's like really well-defined CD pipelines that will deploy that change to production. Most teams are like mostly CD, if not fully CD, meaning that like there's no manual step to go to production. You probably release to production once a week or once every 2 weeks, most teams. Some services have special cases where they can't do that, but most in general. And you have really good integration tests that run every step along the way. There's a code review step that is enforced. There's integration unit tests and integration tests that run at every stage. There's really good monitoring and observation and logging and alarming that happen in production. And there's also like blue-green deployments and canary deployments and stuff that happen in production. So when your change hits production, if something goes wrong, you're gonna know about it right away. The person that's doing the deployment, which is just usually just clicking a button, the alarms are gonna start going off, and someone's gonna get paged, and you're gonna have to roll back that change. So the main difference is like how you deploy the code and the quality control process and getting that out. That's the difference that I've seen, because when you have a service that's serving like 1 million requests per second, like if it's down for a few minutes, like that's your SLA for the whole year gone. There's no margin for error for AWS services. Like the internet breaks if your service breaks, right? So basically, you gotta have like alarms that fire instantly. You gotta have really good monitoring, really good logging, that kind of stuff. That's kind of where the differentiator is. Anyone else?
Got a question with Lambda. Deploying those functions to Lambda, is that as scalable as the number of functions it uses, or it's not a function of time at all? It's not a function of the number of those functions?
If it's a function of the number of functions if you're deploying all of those functions at the same time. But if you're just deploying a single function, it doesn't matter how many functions you have.
Got it. So if my PR is changing essentially like a few functions, it's not a concern.
No.
But if you're making a release of, say, 10,000 functions,
yeah,
now you gotta wait 12.
Yeah, that's right. But which is less likely to happen, and you can also deploy those in parallel too. There's no reason why you couldn't deploy like 100 at a time in parallel. There are limits on how fast you can call the API, but it's still pretty high. So, any more questions?
Something that sort of scared me or slowed me from going to serverless in the past was just like, in the traditional sense, if something goes horribly awry, I like logging onto a box and generally there's some sort of audit log there somewhere.
Yeah.
So in serverless, you're sort of just left to ensure that you have really good CloudWatch logs. Is that sort of as far as you can get with that? Or
yeah, that's pretty much
okay.
it. Which is, it's a little weird at first. You can't SSH into a Lambda function, and you never will be able to.
Yeah.
And so you can emit custom metrics from the Lambda function too. So Lambda has a few built-in metrics that you get, like errors and latency and stuff like that. You can also emit metrics from your code, and you can obviously emit logs from your code. So with just those primitives, you can do a lot of monitoring, and debugging. Like you can set up filters on your logs, you can set up alarms in your metrics, and so on. So you have all the pieces you need, but it's like a little bit of a weird shift when you come from traditional application.
You get some tools like, say, New Relic or Rollbar, those kind of tools in traditional application.
Yeah.
Is there a need or a replacement for those types of tools?
Yeah, good question. So there are actually companies that exist today to solve that problem. It's one of the gaps kind of that AWS has, which is you can't really get like really good fine-grained monitoring on your functions. You get, like I said, you get errors and latency and a few metrics, but not a whole lot of insight. Nothing like what New Relic would give you. So there's companies that exist today. Basically, the way most of them work is you take some of their code and bundle it into your function. So their code is actually running inside your Lambda function, and it's emitting metrics and logs and stuff on behalf of your function. So it's a little hacky. It's kind of weird the way it works, but there's a gap there for sure. And I think AWS is working on like improving some of that too. So it's gonna get better.
Stay tuned
Yeah.
Chad, you all right?
So, you give a demo like this, and there's like 8 pieces of technology that you stitch together. If someone is getting into it, that seems really intimidating to try and learn a broad swath of technologies all at once.
Right.
So, if you were to recommend to a newcomer to be like, start here and work your way out, what would that process look like?
That's a really good question. I didn't mean to intimidate anyone by throwing a bunch of services at you. But the truth is, like, AWS services kind of work well with each other. And to build useful applications, you do need to compose a few together. My old manager used to call API Gateway and Lambda the peanut butter and chocolate of AWS. So, like, probably, like, for a real-world application, the static website in S3 is a great one. It's pretty easy just to walk through the steps to deploy, say, a JavaScript application running in S3 and maybe set up CloudFront in front of it. And then you have an application. And then to take that a step further, the next level would be to put API Gateway behind it with maybe DynamoDB. So you can kind of keep doing it iteratively to kind of keep making it more complex. You can make really insanely complex, like Rube Goldberg architectures with AWS, because all the services are designed to integrate with each other. And actually, that's kind of a trend that you do see with serverless, is that because you don't have servers now, you can basically wire up all these different events to each other, and then your architecture becomes this sort of crazy mess of events that just like bounce around all these different AWS services. It becomes really hard to kind of reason about. At the same time, it just kind of works, and you don't need to worry too much about monitoring it because the managed services set you don't really need to worry about. So,
Once you create a positive feedback loop.
that happens. So, but it depends on what you want to build. Like any kind of application that you want to build, I think you can come up with a pretty simple architecture using these services that would work for it. But it was.
I guess the hello world of this would just be a Lambda that returns hello world and an API gateway layer on top.
Yeah, and actually, and you actually don't need the API gateway later either. You can just build a Lambda function, and you can invoke the Lambda function through the AWS CLI. So you can build a hello world in Python, and you can do it right in the console. You don't even need to like package it up or anything. You go on the Lambda console on the website, the AWS console. Copy and paste hello world in Python or Node into the function, and then run AWS Lambda invoke, name of your function, and it'll spit back hello world. Like that's really the shortest path to getting it working.
Cool. Well, thanks again.
All right, thanks guys.
So, whoa, that's really loud and very close to me. Shit. Okay. So yeah, thanks again, Ryan, for the presentation. It was awesome. We won't be having a meetup next month, but we might. I don't know. We've been tossing around the idea of maybe doing like some sort of get-together type thing, but like not a traditional presentation or anything like that, because it's like holiday time and nobody has any time for that kind of stuff. So that might be happening, but no guarantees. Is there anybody here who has any announcements in the community? Is there anything going on in the next month or so that people want to get out? Anybody hiring? No? Everybody's cool. Oh, Scott, yes.
Well, I'm just speaking for game dev and now, so I think they're still looking for volunteers.
Yeah, well, we're if anyone would like to help us organize, then we're really looking for people that have a little bit of time to spare. I know it's a very busy time of year.
Right, and fragment is for Global Game Jam. So
Global Game Jam 2019. So we did it last year.